My last guest today is from the Science Education Program here at App State to tell us how science and learning can be fun. And how are you, Jeff?
I'm doing great. How are you?
Great. I'm doing great. Well, tell us what you do in the Science Education Program.
So I work with people who are going to be teachers, and I'm really interested in helping teachers think of themselves not as knowledge dispensers. You know, we often think teachers are there to give knowledge, but to help people who are going to be teachers think of themselves as enthusiasm engineers. Because knowledge, you know, in the end, now is on people's phones. The information is there, but the ideas have to come along with passion.
Definitely.
And so young teachers need to be thinking of themselves as people who are going to help develop passion for knowledge, and they do that through becoming enthusiasm engineers.
Well, I can tell already you're very enthusiastic about what you do, and I love it. I love hearing that. So why is science to you so important to learn and keep in our schools?
Well, so in our human history, being curious has been really significant, right? If you think of a tribe, earlier Dr. L was talking about folks who are walking around 10 or 20,000 years ago. That group of people had to be curious. If there was a broken branch when they woke up, was that somebody that was trying to get them some animal they could eat, some animal that might eat them? Curiosity is baked into our cultural and genetic.
From a little age, from babies.
Yeah, and from historically, all the way back through our evolution. So let me give you an example, okay? So I'm going to show you something. I'm going to pretend that I have some magic glue here. I'll pretend it's in here in my pocket. And I'm going to show you that the glue is not sticky at all, which is kind of a bummer for glue, right? You want glue to be sticky. Turns out that this glue is only sticky if it's in the dark. So now it sticks, okay, right? But if I hold it up here in the light, it comes unstuck, right? So let me get some more of this magic glue in here now. Right?
Okay.
I love your face.
Okay.
You see, but you really want to know how this works. You see how your brain right now, you're thinking, you're trying to figure it out, right? Not sticky at all, right? But I put it in the darkness, and then it sticks, and then it comes unstuck when it's in the light. Now, there's not any magic glue. Obviously, you know there's not magic glue because my pocket would be glued shut because it's dark in there, right? So but there's something in here that allows me to stick that rope.
And there's something in here that makes me want to know what you're doing.
Yeah, and see, that desire to know is something that everybody is born with, and that we can maintain our whole lives. And I'm convinced that if people keep that alive, they keep alive some other things, which is a curiosity not just about this bottle and how it works, but a curiosity about the physical world. They start to care about, oh, that flower, that plant, what's the name of that plant, and why does it bloom then? And wow, maybe I should oppose the people who want to put in a parking lot here because that plant grows there. And you know, they might start being curious about one another. So I think that curiosity here can translate into empathy, curiosity that bridges gaps between people. I really believe this. It's not just something I say. Like, I actually think that if we get curious about the physical world, and if we learn to find curiosity in our own hearts, we'll also learn to be better to one another.
Well, in your lessons, how do you intrigue people? How do you keep them curious in your classroom?
Well, one is by having good props, right? No, but I think that some of it is by being curious myself.
Yeah.
Right? So I have to be on the lookout for things that make me wonder, right? I started a project a long time ago. I didn't know what to call what I did with my life. Like, my college would write and say, what are you doing? And I teach a lot of different kinds of things. So I decided to just call it human wonder research.
Yes.
And so I try to do human wonder research, figure out what makes people intrigued, and then to follow that.
Well, I know that you have a science experiment that I'm sure is going to not only intrigue me, but our viewers. So in a little bit after our break, you're going to show us this experiment, right?
And can I say one thing to the people out there?
Yeah.
So if you want to know how this bottle works, all you have to do is email me how you think it works. Doesn't have to be right. And I'll send you a video of me making it with a clear bottle.
You'll have all the steps.
Absolutely.
Okay, well, when we come back, we're going to learn about not only, I guess,
I'm not telling this one.
You're not going to give away the secret?
Not yet. You got to send me. You see, here's the thing. I want people to be curious.
Okay.
So if I just give it away, that's like looking it up.
You're right. Pointless.
You
All
go
right.
ahead and give it a shot.
Well, when we come back, we're going to be doing one of Jeff's very fun experiments. Stay tuned. Hi neighbors, we're back with science educator Jeff Goodman, and he's here to show us a little science fun, right?
All right, so here's what we have here. We've got an apparatus that you already are wondering about, right?
I am wondering.
So what does it look like to you?
It looks like PVC pipe.
Okay, so PVC pipe often used in plumbing, right?
Yes.
Well, we're going to use it to move some stuff around, but it's something different than we use it to move around in our houses.
Okay.
So take a deep breath. Now breathe out. Okay. Remember what gas you breathe out?
Methane.
I hope not.
I don't know.
No, carbon dioxide.
Okay.
You breathe out carbon dioxide.
Sorry, I was thinking of cows.
Yeah, well, yeah, that's the other end. But anyway, carbon dioxide. So
Okay.
Carbon dioxide is what plants take in to
Yes.
create cellulose. Anyway, it's the gas we breathe out. We breathe in oxygen, we breathe out carbon
Okay.
dioxide. If we were to take those carbon dioxide molecules, which when they come out of your body are far apart, they're a gas, they're moving like this.
Yes.
Okay? They're moving fast and they're a gas. If we were to take them and cool them down, we would slow them down. Okay, that's what heat
like
is.
that.
What heat is the wiggling of molecules. So if they're wiggling fast, we say they are high temperature. If we get them down to negative 78.6 degrees Celsius, they'll turn into a solid. It's freezing of carbon dioxide
Yes.
gas. And I have some frozen carbon dioxide gas right here.
Oh.
So this is at negative almost 110 degrees Fahrenheit or negative almost 80 degrees Celsius. It's very cold. I don't want to touch it with my bare hand because it could give me frostbite.
Yeah.
So I'm just going to take a little chunk of it out. And I'm going to just show you what happens if I warm it back up again. Remember I said that they're frozen, it's a solid, they're just wiggling
Slow.
in place. But if I get them warmer, they're going to jump back out into vapor form.
Yeah.
It's called sublimation. And you can see it here, if I put it in here, you can see that it's bubbling.
Yeah.
Right, that's the molecules jumping back out into gas form. That's carbon dioxide bubbles. And it's actually pulling up some water vapor, and that's what you're seeing at the top. That's a cloud. You're just seeing some water vapor and some carbon dioxide there, right?
Yeah.
Okay, so the other danger with this stuff, I just want to say this because we're showing it on TV.
Definitely.
Okay, is that you never want to put it in an enclosed container because as it turns from solid to gas, it takes up a lot more space and it'll make any container explode. And people get blinded and hurt
Oh my
every year
gosh.
because they put it inside something with a tight cap. Now luckily
Not smart.
this is not enclosed container, there's no problem with this.
Yeah.
But what I'm going to do now is I'm going to put it in here. Now I'm not too worried about it here because this is not closed off. Even when I put the cap on here, it has an opening there,
Yes.
so I'm not worried about anything exploding.
All right.
I'm just going to put some in here. Remember, these are very, very slow wiggling molecules, but I'm going to get them to wiggle faster. What do I need to do to get them to wiggle faster?
Heat them up.
I have to heat them up, exactly. And I've got some warm water here to heat them up with, okay?
All right.
So I'm going to pour some warm water in,
Okay.
all right? And you can hear it,
Oh,
right?
you can hear it.
Right?
That fog.
And yeah, fog coming out. Now I'm going to cap it off. I'm not worried because I've got this end open.
Okay.
And it's going to come out of that end. Okay? This is what it feels like to be inside a cloud.
Oh my
Right there. Does that
gosh.
feel good?
Yeah, it does.
Okay,
That feels
now-
great.
That's carbon dioxide with some water vapor coming with it. What I want to do, though, is play around with this a little bit. See,
Okay.
the key thing in science, that's cool right there
Yes,
already,
it's
right?
already awesome.
Right? But I'm going to put a little soap in this water.
Oh, no.
Give it a bit of a stir. And then we can see what happens when we can blow some bubbles with it.
Oh.
Now those bubbles, try to catch one. Up, up, up.
Oh my
now
gosh.
if you haven't showered recently, you can
This is
always,
perfect
you can-
to
right,
go
you-
shower, right?
yeah. Like that. So what I love to do in my classes and when I go out into the elementary schools or have elementary
Yeah.
school kids come out to visit me is I love to get them to begin to think about things that they want to try with this, right? Because we're messing with it. What happens if I just go like this and just hold it there, right? Whoa, that's pretty cool. Or what if could I blow up? Whoa. See, we just discovered something. Maybe, I don't know. How could we get it so that it didn't break on our hand? I wonder if my hand were soapy, if I could get it to hold, maybe I could get it to, it doesn't seem to work. I wonder, maybe if I put more soap or
Yeah.
less soap, or if I did it with a glove. But those are the kinds of
Questions.
things that you start to do with this. And as long as you're being safe, you
Have
can just
fun.
mess around.
Yeah.
Exactly.
This is awesome. So how does it matter what the shape of this is in order to get it to work
That's
right?
a good question. Did you see that? We almost got one to bounce. Yeah, let me see.
I love when they bounce.
Oh, yeah. Oh, no, that one didn't.
That one's a good
see,
one.
that one didn't. I wonder. Whoa, bounced off of. See, just feel what's happening inside your brain as you do this.
How can you figure it
That's
out?
what drives all science. But the shape of this thing. So I made this so that it would be like what I call a leaky faucet. It kind of looks like a faucet.
does.
It could be any shape that you want. It's nice if it comes narrow down here. I noticed that it wasn't blowing very good bubbles, and so I cut some little grooves here. Again, you're always having to mess
Thinking
with
and
stuff.
tinkering.
Exactly,
Got it.
thinking and tinkering, and not being afraid to try something different.
I love it.
And look, okay, just one last thing. I want you to just notice, because we're
Okay.
moving quick, but notice the colors on the outside. You see some little bits of pink,
Yeah,
or what we call
they're
magenta,
yeah.
rainbow. I wonder why bubbles have rainbows. See, we just generated another question. We could go look that up. Why do bubbles have rainbows on them? And let's see if there are any other questions. Gosh, I wonder why it's that shape, and I wonder why it lets go sometimes. And why is it going
It's why
slower
some
now?
are bigger than others.
Yeah. And the reflection
Love
of the
it.
lights, and see it's going slower and slower, less and less coming out. I wonder why. What would happen if we poured some more water in? What if we tried cold water versus hot water? What if I put some more dry ice in? See, there's so many things
There's
you can
so
do.
many questions with just this simple experiment. You've already come up with like 7,000 questions.
Yep.
Your brain is never stopping.
That's right.
All right, Professor Goodman. Sorry about that. Well, this is the coolest thing I think we've done on the show, and I really hope that maybe we can have you back